Hello everyone, welcome to Cruise Biology. Here we will discuss about the preparation of CSIR NET. Everyone are preparing for the CSIR NET, but along with the reading of the chapters, it is also has become very necessary to prepare for the MCQs. So we will discuss topic by topic in this our schedule. So first of all, let's start with the module number 3, which is your genetic organization and chromosome. So first of all, this is the first question. Here I will give you a question and you have to answer it within 15 seconds. So let's start. First of all, here is the first question. Which of the following is common to both E. coli and eukaryotic chromosome? Once again I am repeating. Which of the following is common? See here, they have asked about the common things between E. coli and eukaryotic. So you can easily understand they have asked about prokaryotic and eukaryotic, the common thing. The common thing between prokaryote and eukaryote. So these are the four options. A. DNA is circular. B. DNA is negatively supercoiled. C. DNA is contained in the nucleus. D. DNA is packed into nucleosome. The similarity they have asked. So you have 15 seconds to answer it. Your time starts now. Okay, your time is up. So the answer is B, which is DNA is negatively supercoiled. So this is the thing which is common between prokaryote and eukaryote, because we know like DNA is not circular anymore. DNA is contained in nucleus. This is only true for eukaryotes, not for prokaryotes. Okay? DNA is packed into nucleosome, but we know that prokaryotes do not have nucleus, nor neither nucleosome. Next question. How do eukaryotic genomes differ from prokaryotic genomes? In the first question, they have asked about the common things. Now, we have to find out the difference between prokaryote and eukaryote genome. These are the options. DNA is circular and single-stranded in prokaryotes. B. Intervening sequences are present in eukaryotic DNA. C. DNA is complex with histone in prokaryotes. D. DNA is organized into operons in eukaryotes. Your time starts now. Read carefully and answer the question. What is the difference between the eukaryote and prokaryote genome? You have four options and the answer is B, which is intervening sequences are present in eukaryotic DNA. So, these intervening sequences, they are not present in the prokaryote DNA. Now the next question. C-value paradox suggests of us about. You have four options. A collinearity between genome size and complexity of organism. Non-collinearity between genome size and complexity of organism. C. Dosage compensation. And D. Number of chromosomes. Your time starts now. Here they have asked about what is C-value paradox. So you must be clear-cut with the its concept of C-value paradox. The option is B. Non-collinearity between genome size and complexity of organism. So it means it has nothing related with the genome size and complexity of organism. Next, in gene regulation, open reading frame, which we call ORF, implies for. Here are your four options. A. Intervening nucleotide sequence in between two genes. B. A series of triplet codon not interrupted by a stop codon. C. A series of triplet codon that begin with the start codon and end with the stop codon. D. The exonic sequence of a gene that corresponds to the 5' UTR of mRNA and thus does not code for a protein. They were asked about gene regulation. Your time starts now. ORF, which is open reading frame, that is implied for what? Read carefully or follow options. In exams you will have such kind of option which will make you confused. Read carefully. And the answer is D. A series of triplet codon not interrupted by a stop codon. Next question. P element. These are the four options. P element is about or what? P element is a transposon. B. P element has a role in hybrid dysgenesis. C. It occurs in D. melanogaster. Or D. All of the above. Your time starts now. You should be clear about what does it P element and what kind of role it has, where does it found, in what kind of organism it is present. Your time's up. So D is the option, which is all of the above. So P element is a transposon. It has role in hybrid dysgenesis as well as it is found in D. melanogaster. So the right answer is D, all of the above. Next question. Mobile genetic elements present in human genome are. Now, it has been specifically asked about human genome. So mobile element, which we also known as transposons, right? So those in human genomes are. These are the four options. Line, which is long interspersed elements, short interspersed elements, P elements and IS elements. But here it is little bit complex, like you have to think twice. Like option A is 2 and 3, means signs and P elements. Option B is 1 and 2, means line and sign. Option C is 1 and 3, which is line and P element. And option D, which is 2 and 4, which is sign and IS elements. Your time starts now. Mobile genetic elements are present in human genome. They are mostly recognized as option B, which is A and B, that is line and sign, long interspersed element and short interspersed elements. Next question. Dosage compensation in Drosophila is achieved by. Here are the four options. Hypoactivation of both X chromosome in female, hypoactivation of both Y chromosome in male, hyperactivation of both maternal chromosome in female, D. Hyperactivation of both paternal chromosome in male. Your time starts now. Once again I am repeating the question. Dosage compensation in Drosophila is achieved by. And these are the four options. Read carefully. Don't make mistake. And the answer is hyperactivation of both paternal chromosome in male. Next question. X chromosome activation is. And these are your options. Yielding a completely inactive X chromosome, yielding a mostly inactive X chromosome, controlled via two special non-coding RNAs, controlled via two specific protein, GIST and P6. These are the four options. Only A, only 3, only 2 and 3, and 1, 2, 3. Your time starts now. You should be clear about the X chromosome inactivation concept. Guys, practice more and more questions. Be with us. So this is the answer. C. 2 and 3. means yielding a mostly inactive, not completely, and 3. Controlled via 2 special non-coding RNAs. These are the 2 options which is your answer related to X chromosome inactivation. Next question. Transposable elements. These are the 4 options. Are specific DNA sequences that move within and between chromosomes, can alter the expression of neighboring gene, have been discovered in corn, fruit fly, bacteria and humans, and 4th is composed a significant portion of a human genome. Your time starts now. Transposable elements is also known as the jumping genes. These are the part of genes which get excised from one place and get placed into other place. Your time up. The answer is PQRS. PQRS means all of the above. So, answer P is also correct. Means these are the DNA sequences that move within chromosomes. For example, this is your DNA sequence. So, it may get excised from this segment too, and it may get placed to another chromosome. Second thing is it can alter the expression of neighboring genes. So it has capacity to alter, because if the gene or the sequence, earlier this gene was coding for A amino acid, but after the interruption of transposon, now it is coding for the B amino acids. So protein expression will be different. Now, have been discovered in corn, fruit fly, bacteria and human, which is also true, and it composed a significant portion of the human genome. So in human genome, it is found in case of human genome. Next question. Transposition differs from other mechanism of genetic recombination. How transposition is different from the genetic recombination mechanism? These are your options. A. Occurs only in bacteria. B. Moves gene between homologous region of the DNA. C. Plays little or no role in evolution. D. Scattered gene to new loci in the genome. Your time starts now. Once again I am repeating the question. Transposition differs from other mechanism of genetic recombination because how does it differ from the genetic recombination? Think twice about each and every option. Your answer is C. It play or no role in evolution. Transposition does not have any kind of role in evolution. So thank you so much for being with us. Don't forget to like, share and subscribe this channel. Don't forget to press the bell icon. Hope you guys like this video and it will be useful for the CSIR NET preparation. We'll meet you again for the new important question related to CSIR NET. Till then, read more and prepare well. Thank you once again.